Hello friends, welcome to my channel. In today's session, we're going to cover Stream API in Java 8. Without get delay, let's get started. So what is Stream API? A Stream API is used to process collection of objects. A stream is in Java is a sequence of objects that supports various methods which can be pipelined to produce the desired result. The Stream API is introduced as a powerful abstraction for working with sequence of data in a functional and declarative way. It allows you to process data in a more concise and expressive manner compared to traditional for loop or iterative approaches. So the point two is clear, right? So it basically treats the collection of data and it creates the pipelines, and with the help of pipelines, and it will apply the some terminal operation. Some kind of iteration process and get the desired output. So let's see what Java Stream features. So the features of Java Streams are mentioned below. A Java Stream is not a data structure. Instead, it takes inputs from the collections, arrays, or IO channels. Streams doesn't change the original data structure. The only provides the result as per the pipeline method. So each intermediate operation is lazily executed and returns a stream as a result. Hence, various intermediate operation can be pipelined. Terminal operation mark the end of the stream and return the result. I guess the point three, what it tried to say, like the intermediate operations are lazily executed until you invoke terminal operation. Your intermediate operation will not execute it, right? So let's see what is these two and what are the methods are available for this given operations. Okay, let's go to the next. Since Stream API has Stream class has different types of operations. Like there are two types of operations in streams: intermediate operations, terminal operations. So here I provided you one simple workflow to show you how it works. So input, basically imagine you have array list, collection of some string or collection of some object. Okay. So from this collection, I'm going to create a stream, that is pipeline object. So when I call streams method, my all collections will be converted into pipeline, and I'm going to apply some operation, like say filter, any operation, filter. We have map. I'm going to give a detailed definition of those methods. But now just imagine these are the operations. So once these operations are ready, then it returns the stream at the end of this intermediate operation. And then terminal operation, basically terminal operation, it is going to do some process where it converts some stream data into some object conversion. Okay. So once the object conversions, all the calculation, everything is applied, then finally we'll get the uh, output of the desired data which you are expected, right? So this is very simple workflow. So let's see what are the functions, means the methods are present in the intermediate and terminal operations. Let's go to the next slide. So intermediate operations, these are the methods: filter, map, peek, limit, skip, sorted, distinct. So filter, the Java filter method allows us to sustain elements of the element based off the specific condition. It is used to apply a certain behavior on the stream items. This method takes a predict as an argument and returns a list of elements that matches the predict. So basically, the filter accepts the argument as a predicate. Already we discussed predicate functional interface, right? just it returns true or false for given expression, right? So we are going to give, let's say I have a list of employee object in a collection. I want to filter that collection like the age is greater than 30. Then I'll be creating one predict condition where I'm going to apply in this filter so that all this data will be filtered and it will go into the level, terminal operation level, right? So, so the filter it returns the streams, okay? That is the return type of it. And map. This method takes a function as an argument. This also already we discussed in our previous sessions. Like function is one of the predefined functional interface. This function has argument and applies to each element of the stream, which will produce a new stream of mapped elements. For instance, we can use this map to convert a stream of strings to stream of integers. Like say, I have a string. So the list of string, I want to convert this list of string to integer. All the numerical string values I'm going to I want to convert to a integer value. So then map method will be suitable for that use case. You can just transform that into the integer from string to integer. That conversion can be done using map. It's internally passing the functional interface as an argument. Okay, next one is speak. We can use the speak method to print the result of each intermediate operation. For say, what is like if I want to see, you can't visualize the data, what is going between the intermediate operations, right? If you have your peak in between the operation, you can see the data, what is flowing on. If you want to specifically log some data, yeah, you can use this peak method. And limit. The purpose of using limit method is to restrict the size of output to specific limit. For say I have a collection of 10 elements. I have collection of 10 elements. Yeah, as I told, right? The limit, basically, right? If I have collections which has some 20 elements, I don't want to process all those 20 elements. Just I need to process first 10 per se, right? So that scenario, you can go with this limit. Limit will accept integer number as an argument. So you can pass what value that you want to limit your collection process. So skip. We can discard the first nth element from the result using skip method. It takes an integer as an argument that specifies those elements will be get discard. For say, as I told you, my list contains some 20 elements. I don't want to process 20, right? So first 8 I want to ignore. I don't want to process it all. So you can skip those first 8 elements while using the skip method. And sorted. This method can be used as sorting the elements of the stream in ascending order by nature. Okay. And if you want to descending it, we can use the reversed method to support the descending order. Distinct to remove the duplicate from the elements of a stream, we can use this distinct method. So like say I have a list of string. In that we have some duplicate strings. If I want to remove those, then the distinct will be used for that. So it will ignore the duplicate and it will make sure all the data will be unique. I mean value is unique. So okay friends, so intermediate operation methods we covered. Let's move to the next terminal operation methods. Any match. The Java stream any match method is terminal operation that takes a single predicate as a parameter and start the internal iteration of the stream and applies the predicate or parameter to each element. That means I want to match any one, like I'm creating one predication that predicate. Already we know what is predicate. It gives us the result for whether my condition is true or false. The any match means any one of the element is matching this my predicate condition. That is the use case of it. And the next one is all match. So for given predicate, the all the elements should match. So then only it will process to the, I mean, it will try to get the data. If it doesn't match, then it will always give the true. I mean, false. So none match, it's the same. The Java stream none match method is terminate operation that will iterate the element in the stream and return true or false, depending on the whether on the no element is stream matches the predicate passes to none match as a parameter. This also is understandable. And next, collect. The Java stream collect method is terminal operation that start the iteration each that element in the stream to collected as an or collections or object of some kind. For example, I have filtered some data and I have done some kind of calculation. Everything is done and transformed to the data, and I want to convert it to some list or map. So that scenario, it will be collecting all the filtered data and it will create the object. And count. Count basically gives how many elements are in the stream. So this is an terminal just giving the numbers. And we'll go to the next slide. For each. For each, already we know it is a kind of for loop kind of process. It's a terminal operation that starts the internal iteration and that then applies the consumer. It accepts the consumer as an argument to each element in the stream. So it's a for each method returns a void. It doesn't return any value. It's a void kind of approach. And min, the min method Java stream means it returns the minimum smallest element in the stream. And max, the Java stream method is terminal operation that returns the largest element in the array. Reduce, this the Java stream reduce method is terminal operation that can reduce all the elements in the stream to be single element. Just it converting. I have some list of integers. I need to find the sum of it. So you can use this reduce method, or you want to sum of your Fibonacci series. So that kind of calculations we can prefer to use reduce. To array. The Java stream to array method is terminal operation that starts the intermediate iteration to the elements in the stream and returns any arrays of objects containing all the elements. And the next two, find any. This is also accepts the predicate as an argument. If anything is fine, and gives the result. And find first, no, find it, sorry for that. Find any means for given list, it will find any one single element from the string. That element found can be anywhere in the string. There is no guarantee about which is the stream and the element is taking. It will pick randomly. Okay. And the find first. This is always preferred to pick the first element, and it's a type of optional which you can obtain the element in the presence. Okay, friends. So far we covered in the theoretical definition. So in next session, I'm going to give you a live working session. So thanks for watching.